Welcome to part 1 on exponential and logarithmic equations. The first part of this section will focus on the exponential equations, and to solve them with an unknown as the exponent, we will 1. Isolate the exponential term on one side, and then 2. Take the log or impose the log of each side. We could use log or ln for this process. Okay, so use laws of logarithms to bring down the unknown variable as a multiplication and then solve it. So sometimes you might see an exponential equation of quadratic type, and in this case you would suppose that y equals a to the x, where the x portion is quadratic, and then you'd factor it. We'll talk about that further if we come across one. So let's look at the first example here. We have 2 raised to the x equals 24. We'll use the natural log, and then we'll use log base 10, the common log. We can use either one and it will still work. So I'll impose a logarithm on both sides because it is an exponential equation. When you have exponential equations, you undo them with logarithms. I can bring the x out front. This is why the logarithm is so important. So I can bring the x down as a multiplication. Then I just have x times natural log of 2 equals natural log of 24. And this can be solved for x simply by isolating the x, by dividing both sides by the natural log of 2. And I get x is equal to the natural log of 24 divided by the natural log of 2. If I want to know the exact number on that, I just take the natural log of 24 and divide it by the natural log of 2. And I'll get approximately 4.58. Now let's use a log base 10, a common logarithm. We will do the same exact process but with a common log. So we'll take log of both sides, so we'll have log of 2 to the x equals log of 24. Then we'll bring the x out front as a multiplication, so x times log of 2 equals log of 24. And then we'll divide over the log of 2 to isolate the x. And my x is equal to log of 24 divided by log of 2. And if we put that in our calculator, log of 24 divided by log of 2 equals 4.58. So you can see that they come out exactly the same whether you use a natural log or a common log to solve them. We have another exponential 500 times 1.02 raised to the t equals 600. Now remember, I have to isolate the portion of the equation that has the exponential variable. Therefore, I will divide both sides by 500 to isolate the factor that has the t as the variable in the exponent. I can also reduce the common 100 in both the numerator and denominator. So now I have 1.02 raised to the t equals 6/5. Now I can impose a logarithm on both sides. I'm going to use a natural log. When I do that, I get the t to come down front, and I get t times the natural log of 1.02 equals the natural log of 6/5. Now I just divide both sides by the natural log of 1.02 to isolate t. And I get t is equal to the natural log of 6/5 divided by the natural log of 1.02. The natural log of 6 divided by 5, close paren, divided by the natural log of 1.02, close paren. And I get 9.21. Let's try e to the x plus 2 plus 5 equals 60. I need to isolate the part of the equation that has a variable as an exponent. So I will subtract 5 from both sides. This gives me e to the x plus 2 equals 60 minus 5 is 55. Now e is my base, so it's a really obvious sign that I should be using a natural log as my log to impose on both sides. When I do that, I will have the natural log of e, and I can bring that x plus 2 out front. So x plus 2 times the natural log of e equals the natural log of 55. Then I happen to know that the natural log of e is just 1. So I don't even have to rewrite that part. I just have x plus 2 equals the natural log of 55. So if I subtract 2 from both sides, I get x is equal to the natural log of 55 minus 2. And I get 2.00733, etc. So we'll just go to 2 decimal places, so 2.01. Next, we have e to the 2x plus 4e to the x minus 21. Notice that the exponents are in descending order. We have e to the 2x, we have 4e to the x, and we have a minus 21 equals 0. I'm going to see if I can factor this. I know that an e to the x times an e to the x would give me an e to the 2x, because when you multiply bases, you add exponents. I also know that 21 can be found by multiplying 3 times 7. And if I want a sum in the middle to be positive 4, my 7 would have to be positive, and my 3 would have to be negative. Now I can set each one of my factors equal to 0 and solve for x. So I'll have 2 different factors. I'll have e to the x minus 3 equals 0, and e to the x plus 7 equals 0. So these are my 2 equations. Now if I isolate the term with the x as the exponent, the variable as the exponent, I'll have e to the x equals 3 and e to the x equals negative 7. Now I will impose a natural log on both sides of the equation. And I should get a red flag here. This is a problem because you can't have a natural log of a negative number. And so I'm gonna just throw out this scenario because that one will not work. You can't have that situation. You get does not exist equals x, and that doesn't make any sense. So that's wrong. On this side, we have natural log of 3, and that is possible. We can bring that x down front, so we'll have x times the natural log of e. We happen to know that the natural log of e goes to 1, and so I have x is equal to the natural log of 3. Next, and lastly, for the exponential equations here, we've got 6 to the 4x equals 46,656. So we're going to take log of 6 raised to the 4x equals log of 46,656. I'm going to bring the 4x down front. So that gives me 4x log of 6 equals log of 46,656. Then I'm going to divide both sides by log of 6. And I'm also going to divide it by the 4 on both sides because I need to isolate the x. So I get x is equal to log of 46,656 all divided by 4 times log of 6. Let's put that in our calculator and see what we get. In the numerator, log of 46,656 divided by, now since I have 2 factors in the denominator, I'm going to put parentheses to group the denominator separate from the numerator. So open paren 4 times log of 6, close paren, close paren. So my answer to this is x equals 1.5. So the moral of the story in this video is to remember that if you have an exponential equation, you undo it with logarithms. So I'm sure you're connecting this. If you had a logarithmic equation, you would solve it with exponentials. And we'll see that soon.